respected our teacher Iftikhar Alam sir and my dear classmate. Assalamu alaikum. I am Imran Hussain and my team member are Al Shari Afia, Abdul Hussain Asif. We are appearing here to give a presentation. Our presentation topics is wireless network security. Contents: wireless network security, security threats for wireless network, wireless security measure, mobile security element, Wi-Fi align, IEEE 802 protocol architecture, IEEE 802.11 service, IEEE 802.11i services, IEEE 802.11i phases of operands. Wireless network security. Wireless security is a prevention of unauthorized access or damage to computers or data using wireless networks, which includes Wi-Fi network. The most common type is Wi-Fi security, which includes wizard equivalent privacy and Wi-Fi protected access. Features of network security: channel, mobility, resource accessibility. Security threats for wireless network: accidental association, malicious association, ad hoc networks, non-traditional network, identity thief, MAC spoofing, man-in-the-middle attack, denial of service, network injection. What is accidental association? Company wireless LANs or wireless access points towards LANs in close proximity may create overlapping transmission range. Malicious association. In malicious association, in each situation, a wireless device is configured to appear to be legitimate access point. In ad hoc networks, these are peer-to-peer networks between wireless computer with no access point between them. Non-traditional network, such as personal network, Bluetooth device, barcode readers. In identity theft, this occurs when an attacker is able to eavesdrop on network traffic and identify the MAC address of a computer with network. Man-in-the-middle attack. Attacks involves persuading a user and an access point to believe that they are talking each other. Denial of service. A denial of service attack occurs when an attacker continuously bombards a wireless access points or some other accessible wireless port. Network injection. In network injection, attack target wireless access points that are exposed to non-filtered network traffic such as routing protocol. Next, in wireless security measures, single hiding technique and encryption. Organizations can take a number of measures to make it more difficult for an attacker to locate their wireless access point. In encryption technique, encryption of all wireless transmission is effective against eavesdropping to the extent that the encryption keys are secured. Now I am going to call my next team member Al Shari Afia.
Here is mobile security elements. The first mobile security elements will request the application to database server, and it first need to configure the device. And for the configuration, the mobile device will go to the configuration server, and then after the configuration complete, it will check the access control. It will go into the access control server to get the access. After getting the access, it can access from the database server. Before the access, the firewall will detect any malware or crimeware or very malicious data which can interrupt the system. The firewall limit the scope of data and the application access. That means firewall will check all the data and limit the access. Here is Wi-Fi Alliance. It is a non-profit organization which are giving the permission or the interportability to the Wi-Fi standards of the Wi-Fi products. Mainly we are using that wireless devices such as a router or any server, and the procedures of these certificates is named as WPA, that means Wi-Fi Protected Access. Here is the protocol architecture of the IEEE, which is named as IEEE 802 protocol architecture, and here is the three parts in there: logical link control, medium access control, and physical layer, which is the lowest part of the, we know that OSI model of the networking. And a logical link control, first the data will arrive into logical link control, flow control by checking the flow control and determining the error control. The data will be passing to the medium access control, and then after checking the addressing or error detection, then the data will be passed into the physical layer. Physical layer is mainly doing the encoding or decoding of signals by bit transmission and through the bit transmission medium. Here is the network component of the architecture model, which is mainly named as, there are two set services. One is basic set services and extended set services. What is basic set services? Basic set service is a group of wireless devices that are working with the same AP, which means there will be some device under a controlled network area, and there will be an access point. What is access point? Access point is like a bridge which connect two types of network, wireless and wired network. Suppose there is a mobile device and a router. There are in which way they are connected, it is called the access point. They are coming through the access point. So there will be access point and some devices will connected through the access point. The access point will have a BSS ID, which is 48-bit hexadecimal code. 48-bit hexadecimal code that can be transformed into 64-bit hexadecimal code, and also it can be basic service ID will the access point will be detected through the BSS ID, which means basic set service ID. And now we are going to discuss about extended set service. What is extended set service? Extended set service mainly are connect by adding one or more APs with another AP, which means that we are mainly connecting two basic set service or two or more basic set service, which will be regarded as extended set service. So there will be a portal, and the whole system is known as distribution system. The mainly access point will be connected through each other so that the data can be shared with each other. Here are the definitions of mainly BSS and ES extended set service, which I am discussed before. And now I'm talking about IEEE 801.11 services, which means mainly the services are related with protocol architecture, and there are 9 services which are in there, and first 6 of them 6 services are used. The first 3 services are used for LAN access and confidentiality. Confidentiality defines that the security or privacy of the data. So mainly LAN access and confidentiality will be checked by first 3 services, and the next 6 services are mainly delivering MSDUs between stations. What is MSDU? MSDU is the MAC service data unit, which is wireless data frame. MSDU contains payload, data payload with the IP packet plus some logical link control data. Now I'm talking about services. There are two types of services: association related services and distribution related services. Association related services are there no transition, BSS transition and ESS transition. No transition means there will be no transfer from one mainly basic service or ESS from there will be no transition. That means no transformation will be happened. BSS transition refers to the transition between one BSS to another BSS in the same ESS. So it have to be in. So if we want to make the BSS transition, we need to have the same BSS in the same LAN. And then ESS transition means the BSS of one ESS will be transferred into the another BSS of another ESS. So we need to have we have to need at least two ESS for ESS transition, but main transition will be happen between BSS. Now distribution related services. Association: establish an initial association between a station and an AP. There will be connection between station and access point. That means the server and the router. The relation between server and router can be defined as association. Reassociation: establish association between an AP with another AP. And transfer between them, we can define it as the connection between two routers. And this association, it can be described as the termination part which of the distribution related services. There an existing AP will be existing AP association will be terminated by getting a notification from the station or AP. A station should give notification of leaving ESS. So notification should come before the shutting down the distribution.
Let's discuss about wireless and wired LAN. Wired LAN and wireless LAN are nothing different, but wired LAN are physically connected and it's a secure network. But on the other hand, wireless LAN is not a secured one, but it connects without wire. Now in wired LAN, any device cannot connect other devices except it is connected with wired. But in wireless, if the range is from the station, the range is from one station to another station, the range is limited, and any station can connect with other station without an wired connection. And now the IEEE 802.11i WLAN. This is a protocol from for wireless local area network. Here are several types of security: WEP, WPA, and WPA2. IEEE 802.11i is named as robust security network. It is very fastest and very secured with the WPA2. And let's discuss about its services. And there are three types of services: authentication, access control, and privacy with message integrity. Here, authentication is mutual authenticate. It means it will connect one devices at a time, and it uses a temporary key to connect and authenticate with other stations or authentication server or access point. And next is access control. It's basically a protocol, and it's it used as to key to exchange key between station and access point or station to authentication server. And the next services is the privacy within the message integrity. We will discuss about those later in slides. Now see the diagram here. As I said before, IEEE 802.11i is called robust security network, and the services and the protocols is used. Access control used IEEE 802.1 port-based access control, and authentication and key generation uses extensible authentication protocol or EAP, and the data integrity uses temporal key integrity protocol or TKIP, and another is CCMP. Now there are the several cryptographic algorithms used within the services. Confidentiality uses TKIP, CCM, and others, so on, edited in the diagram. We will discuss about those algorithms later on in the several phases and operations in IEEE 802.11i. It has five phases of operation to connect with access authentication server and access point. It has discovery phases where it will discover between the devices, and authentication to authenticate the device, and key management to transfer the secret keys between two devices, and the protect data transfer and transferring the data protectly. And after all happens well, and the connection between two devices will terminate. Now let's see the phases of operation used in this diagram. A station at first discovered the access point, and in phase 2 a station authenticate with access point and then authentication server, and in phase 3 station respond to access point, how it will manage the keys, and authentication server responds with access points, and here the main part to transferring data, and at last phase 5 terminating the connection. Let's talk about more briefly about the discovery phase. Here in discovery phase, we need to look at the security capabilities, the confidentiality which is needed. Here several security protocols has been used. WEP is used basically for allowing the backward compatibility. It means it is used basically for basically backward compatibility means to using the old protocols if we updated our modern protocols, and TKIP and others is used to confidentiality and integrity cipher suite. Here cipher suite basically means a set of algorithms and a defined key. Now comes authentication and key management. It uses IEEE 802.1x and a pre-shared key. Both are different though. And the next is how it will authenticate. We'll briefly and there are several here is authentication method. Several authentication method is used, and the cryptographic key management in discovery phase basically the one devices means a station provides its capabilities to access points. That means station will will give its capability to the access point, and access point will decide what to do with the capabilities and transfer the data or authenticate or move to the next phases. And it uses MPDU exchange. MPDU basically stands for MAC Protocol Data Unit. A station transfers its MAC Protocol Data Unit with the access points, and here the procedure is basically it gives a beacon frame to the access point gives a beacon frame and a probe response frame, and an wireless station basically monitor the beacon frame and wants to connect and sends the response as an actively proving. And there are open system authentication maintains the backward compatibility here at MPDU also, and the association also matching the capabilities advertised by the access point. If the capabilities is not same, then in discovery phases station and access point will be disconnected and no longer will connect after all. And now here is the authentication phase. In authentication phase, IEEE 802.1x is used as an access control. It's a port-based network access control, as we said it before, and it uses extensible authentication protocol, which we will briefly discuss about later in key management. And next is EAP exchange. It basically the extensible authentication protocol is exchanging between the station and the access point a message flow generated, and authentication, again the authentication exchanging between the access point and the station, ensuring that the authentication access basically occurs like access point issuing an EAP request to station, and station replies the EAP request and sends an identity frame. It means it will identify itself to the access point. It means station identifies itself to access point. And here's the authentication in briefly, as discussed in here. A station starts with a EAPOL start. It means EAPOL means extensible access protocol over LAN. Started with the AP, and EAP request sends to EAP request sends to station from access point, and again the reply is from station to AP, and then the access request generates from access point to access server, and this replying request is generated. Here you can see a multi-round authentication message exchange. In this multi-round authentication message exchange, it will generate it as much as it indicated in its protocol. Like TLP basically uses 20 round authentication message exchange, and if it's failed, then the station will no longer access the authentication server. And next comes the key management phase. Here is a hierarchy of here is a hierarchy of pairwise keys. Basically, key management uses two types of key hierarchy. One is pairwise key, and another is group. And in pairwise key, there are several types of key used: master session, pre-shared, pairwise master key, and pairwise transient key. We will see it later in a diagram. Here's the diagram. The diagram is basically separated or shows the hierarchy of the pairwise. Basically, pre-shared key is different than MSK. It means if the MSK is generated, then it will not needed to generate a pre-shared key. And as we see that pairwise key comes from pre-shared key or master session key, and pairwise master key generates the pairwise transient key, and then the three other types of key: EAPOL, key confirmation key; EAPOL, key encryption key; and temporal key. Here is the group key hierarchy. Group key hierarchy uses two types of: one is group master key, another is group temporal key or GTK. And this is the group key hierarchy, how the key management phase is used. In pairwise key distribution, access point includes the MAC address of AP and a nonce. It needs to be know what is a nonce is. A nonce is a arbitral key which is generated and used only once in a transmission. And station to AP to station, and station to AP, the key is distributed somehow. We will discuss about it in the next diagram shown in here. It's basically called a four-way handshake and group key handshake. Here access point requested EAPOL key with a nonce, and then station response EAPOL key and S nonce, it means own nonce, and unicast and MIC is basically message integrity code. And then access point again sends another message with EAPOL key and installing the PTK, and then station again responds with the message 3 and sends the message 4 to the access point. This is basically called the four-way handshake. And the next is the group handshake, where the group key is being transferred to station to AP and AP to station. Now comes the protected data transfer phase. In protected data transfer phase, a temporal key integrity protocol is used to maintain the message integrity and the data confidentiality. And a counter, it's basically called CCMP or counter mutex cipher block chaining message authentication code. It also uses message integrity and data confidentiality. In protected data transfer phase, these two types of protocol can be used: TKIP or CCMP, any of it. And here is the end of the presentation about the wireless network security, and it is basically the data transfer phase is completed in here, and the completing the data transfer phase, it basically terminated its connection with the station to access point. Thank you all.